Now, I want to look at a beautiful concept in right angles triangles. If you remember vividly, when we are dealing with trigonometric ratios, let's look at the first quadrant. You notice that this is a right angle triangle because the angle here is 90 degrees. Okay, now let's simplify further and let us understand the concept of Pythagoras theorem. Okay, now the concept is very simple. When we have an angle, a right angled triangle, okay, let's call this A, B, and C with angle theta. The angle facing the side facing the angle is called the what? Opposite. So this is the opposite. The longest side is called the hypotenuse, and the other side is called the adjacent. Now the Pythagoras theorem states that the square of the hypotenuse, is equals to the square of the opposite plus the square of the adjacent. So in essence, we are saying that c squared is equals to b squared plus a squared, which we can also say that c squared is equals to a squared plus b squared. Now, if you apply the same principle of SOHCAHTOA, it's easy. Then we'll just say that sine theta is equals to opposite over hypotenuse, just like we did. Sine theta is equals to opposite over hypotenuse. The opposite in this case is b, the hypotenuse is c. So sine theta is equals to b over c. Similarly, cos theta is adjacent over hypotenuse. Cos adjacent over hypotenuse. The adjacent is a, the hypotenuse is c. And tan theta is equals to the opposite divided by the adjacent. Opposite is b, the adjacent is a. So we are going to apply these principles 1 and 2 so that we understand how right angle triangle coupled with Pythagoras theorem work. Let's begin. Let's see question number 1. In question number 1, we're asked to evaluate the length of the hypotenuse. Let's say we are given this with the angle theta. We have the opposite to be 3, the hypotenuse, the adjacent rather, to be 4. What is the hypotenuse? Now remember from Pythagoras theorem that hypotenuse squared is equals to adjacent squared plus opposite squared. The opposite is equals to 3 because it is the side facing the angle. Adjacent is equals to 4 and hypotenuse is unknown. So applying this, we can say that hypotenuse squared is equals to 4 squared plus 3 squared. Therefore, hypotenuse squared is equals to 16 plus 9, which is 25. So the hypotenuse, which will be the square root of 25, will be equals to 5. Hypotenuse is equals to 5. Now, a time might come where we will not be given 2 sides. Maybe all we're just given is a side and an angle. Let's go to question number 2. We are given a side and an angle. You can see here we are given 2 sides. Now here we're given a side and an angle. So considering that, now let's take an example. We have a right angle triangle and we are looking for, they gave us angle theta to be equals to, let's say, 30 degrees. They gave us the adjacent to be 5 centimeters, and we are asked to evaluate the opposite. Let's call that A, or we should use opposite, and the hypotenuse. So these are kind of questions that we might see when we are dealing with right angles, triangles coupled with Pythagoras theorem. Now, how do we go about this? We are given a side and we are given an angle. Remember, sine theta is opposite over hypotenuse because we are following so quadrature. Cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite over adjacent. So for us to evaluate the opposite now, we are given the adjacent. Good. We are given angle theta, and we are looking for opposites, and we are looking for hypotenuse. So which do we start with? We can use this formula to evaluate the opposites. Likewise, we can use, I think that's the only formula we can use, because we are given adjacent and we want to evaluate opposites. We are given adjacent, we want to evaluate opposites, and we are given theta. So let's begin by evaluating the opposites. So tan theta is equals to the opposite over the adjacent. Theta is equals to 30 degrees. The opposite is unknown, and the adjacent is 5. Therefore, if you cross multiply, the opposite will be 5 tan 30 degrees. Tan 30 is equals to 0.5774. So this is 5 multiplied by 530, and this would give us 2.8868 centimeters. Now we have gotten our opposites to be this, and we are looking for the hypotenuse. Now we can evaluate the hypotenuse in two ways. We can say hypotenuse squared is equals to opposite squared plus adjacent squared, or we use cos theta is equals to adjacent divided by hypotenuse, or we also use sine theta is equals to opposite divided by hypotenuse. We have use this to evaluate the hypotenuse in the first question. Let's apply cos theta and let's apply sine theta. So applying cos theta is equals to adjacent divided by hypotenuse. Theta in this question is what? Okay, let's withdraw the question. We have 30 degrees. We have 5 centimeters as the adjacent, opposite, and hypotenuse. Cos theta now is adjacent over hypotenuse. So cos theta will give us cos 30 degrees is equals to the adjacent, which is 5 centimeters, divided by the hypotenuse, which is unknown. So making hypotenuse over to formula, we will arrive that hypotenuse is equals to 5 divided by cos 30 degrees. So this will give us 5 divided by 0.8660. And we would have this to give us 5.7735 centimeters. In the same vein, if you apply sine theta to this question, we will have the sine theta is equals to opposite over hypotenuse. So quadrature, okay, that's what we are using. Sine theta is equals to opposite over hypotenuse. Now we have evaluated the opposite to be this 2.8868. So we are saying that sine 30 degrees is equals to 2.8868 divided by the hypotenuse. So if we make the hypotenuse out of the formula here, we will have this to give us 2.8868 divided by sine 30 degrees. Sine 30 degrees is 0.5, and using the simplifying this maybe with our calculator, this would give us 5.7736 centimeters. Now we can see that these are nearly the same thing. They're approximately the same thing. So whichever way we evaluate it, we will get the correct answer. So now let's take an exercise. Well, we'll be given different diagrams and we have to use a specific trigonometric identity, maybe sine theta, cos theta, to evaluate a side of the right angle triangle. Remember, we are using sine theta is equals to opposite over hypotenuse, cos theta is equals to adjacent over hypotenuse, and tan theta is equals to opposite divided by the adjacent.